All right, in this lesson we're going to learn about a different kind of margin of error than what we learned before. In fact, black screen. Okay. Back in the day, we first learned about margin of error. I gave you a really simple formula for it. And I said it was going to be plus or minus 1 over the square root of n. Do you remember what n represented? The number that was given, the sample size, how many people or whatever you had. So we just said margin of error. When we talked about the margin of error, we had to use really vague terms. I would say things like, it is likely that the true percent of people that are going to vote for Mr. Smith will be between this and this. I would just say likely. The point of the new formula for margin of error is that we want to be more specific than just saying likely. We want to be able to say exactly how sure we can be. I'm going to say things like, we can be 90% sure that the real percent is in this range somewhere, or 95% sure, or 99% sure. We're going to be real specific. And then that's called a confidence interval. Now, this formula won't be given to you on the test. It's yet another formula that you have to memorize. However, this chart where with the z-scores that you need for any particular confidence interval, this chart will be given to you. Okay? So you've got this formula. This sigma, that's your standard deviation. The n is still going to be your sample size. But the z-score, you're going to pick whichever z-score corresponds to the confidence interval you're looking for. And that's going to be mentioned in the problem. Okay, well, let me say one more thing before we do an example. When the test comes, now that we know two different formulas for margin of error, a valid question that you might ask is, wait a minute, Burton, how am I going to know on the test whether to use the simple margin of error formula or whether to use this new z-score version of the margin of error formula? How do I know which formula to use? The answer is this new z-score version of the margin of error formula is for confidence intervals only. So if the question mentions something about you want to be 95% confident or 90% confident, if the confidence level is mentioned, then you know you're going to use this blue formula. If it doesn't say anything about confidence level and it just says find the margin of error, then you'll use the old simple margin of error formula. But for now, let's focus on the new one. So example 1. I'll leave this visible. Imagine a polling organization surveys 1,000 voters in a city to find out how they plan to vote in the upcoming election. The organization reports that 58% of the survey respondents plan to vote for Smith. The population standard deviation is 25. If they want to report with 90% confidence, let's find the margin of error and the confidence interval. So, of course, we'll be using this new margin of error formula because they're mentioning a specific confidence level. So let's see, which one of these z-scores am I going to use in my formula? Read it. Read the z-score.
1.645.
Yeah, we're looking right here. The confidence level is supposed to be 90%. That means when we use the formula, we will do a z-score of 1.645. Again, this little chart will be given to you. So this will be pretty straightforward, I think. So we're going to have the 1.645 z-score times. Now I need my standard deviation. What's the standard deviation again?
25.
All right, they said that was 25. Over the square root of the sample size. What's the sample size here? 1,000. 1,000 voters were surveyed, so that's the sample size. Okay, I'm going to pause the video for 30 seconds. Put this in your calculator and tell me what you got. Okay, Brett, what did you get for the margin of error?
I got 1.3.
1.3. So this is the number that we will wind up adding and subtracting when we find the confidence interval. Now, adding and subtracting from what? You have to look for where they said something about the sample. Sometimes it'll be just a number, like an average, a mean, but sometimes it'll be a percent. So what did the survey, what were the results of the survey?
58 responded.
That 58%. 58% of the people said they were going to vote for Smith. So we will start with that number, the survey results, and then we will add and subtract our margin of error. Because we're doing interval notation, we want the lower number first. So you should subtract first, then add. So what's the lower bound? All right, 56.7. These are percentages, so I'll go and put that percent on there. And what's the upper bound?
69.3.
Say that again, 59.3?
Yes.
So this means, sure, the sample that we had, 58% of them say they're going to vote for Smith. But what about the entire population that we really want to know about? Well, we can be 90% sure that the true percentage of the population that's going to vote for Smith is somewhere between these two percentages. Skirt. All right, I'm going to do example 2 pretty fast, so try to keep up. A company that produces white bread is concerned about the distribution of the amount of sodium in the bread. The company takes a random sample of 100 slices and computes the sample mean to be 103 milligrams of sodium per slice. Standard deviation 10 milligrams. If you want 99% confidence, find the margin of error. Well, the z-score that goes with 99% confidence is this 2.575. So we'll calculate that way. So the margin of error will equal 2.575 times. In the top, we need the standard deviation, which should be 10. And in the bottom, we need the square root of the sample size, which is 100. You put this in your calculator, and you get 2.575, which you notice is the same thing as the original number before the fraction, which makes sense because the square root of 100 is 10. 10 divided by 10, they cancel out. So, of course, it's the same thing. But we're going to round this to 1 decimal place. So that's supposed to be an eraser, but it's failing. And now the whole thing crashes. So that's great. So we have a margin of error of 2.6. Now, be careful. A lot of kids have trouble seeing what we're supposed to add and subtract from. On the first problem, the result of our sample was a percent. So we were adding and subtracting from a percent. On this problem, we won't be adding and subtracting from a percent. In this case, it's not a survey or anything. It's not a percent that we have. It's an average. It's a mean. So sometimes sometimes the sample will give you a percent, like if you're surveying for voters. But sometimes the sample will give you just a number, just an average number, a mean. So in this case, let's see. The sample mean is 103 milligrams. That's what we're going to add and subtract from. Okay, so 103 milligrams was the average amount of sodium in the sample. So for the entire population, it'll be close to that, but it could be a little bit more or a little bit less, plus or minus 2.6. So do that and tell me what you get for the confidence interval. What's the lower bound?
100.4.
100.4. Okay, what's the upper bound? 105.6. And these are not percentages, right? These are milligrams. So we can be 99% sure that the actual average sodium content for the entire factory will be somewhere between these two numbers. Okay, let's do example 3 together. This is mostly about understanding what each of these symbols mean. That's all. Hold on, let me yell at Cassidy real quick. So, what is N for example 3? Look at example 3, tell me what n is. Put that spinner thing away, honey.
Is it 100?
It is 100. N is the sample size. So we have a sample of 100 observations. So n is 100. What is x bar?
75.
That's your 75. X bar is the symbol for mean. So 75. What is sigma? Sigma is 8, because sigma stands for standard deviation. Now, of course, for the margin of error, we need to calculate that. So we're going to do, let's see, 95% confidence. So to do this formula, we need the right z-score. So what z-score am I going to use this time?
1.96.
Yeah, I'm going to use the 1.96, which goes with a 95% confidence interval. Okay, so here we go. So we'll have 1.96. All right, and then we have the standard deviation over the square root of the sample size. So I'm going to pause the video, calculate it out, get ready to tell me the answer. All right, so what did everybody get for the margin of error? 1.6. And I'm not going to mark it right or wrong depending on whether you put the plus or minus. Okay, that's optional. As long as you know when you go to do the confidence interval. Now, what am I going to add and subtract from?
75.
The 75, all right, the sample mean. So for the confidence interval, we will do 75 plus or minus the 1.6. Okay, so go ahead and give me that. 70.4, 73.4, and then 76.6. Okay, so that would be my 95% confidence interval. All right, now as you do example 4, I'm going to give you 2 hints, and then you should be able to do the rest of the problem by yourself. There are 2 pieces of information that you were given on the other problems that you're not given here, but you can figure it out. Let's start with the simplest one. They don't specifically give you the sample size. They give you the sample itself. You don't have a device in your lab this time, do you, sweetheart? Do you have anything in your lab? No. All right, excellent. They don't give us the sample size, but we're looking at a sample. So what is, you should be able to know the sample size just by looking at this thing. What's the sample size? Here's the sample right here. This is the sample. 16. Right? The sample size is just how many items, how many pieces of data are in your sample. So there are 16 of these SAT scores. So the sample size is 16. So that's hint number 1 to get you started. The other thing that they don't give you is the mean, the sample mean. Yeah, you know how to calculate the mean.
So you just add all those up and then divide by.
You could just add them all up and divide by 16.
You get a
Or-
decimal, do you put the decimal in? Or?
Yeah, you go ahead and keep the decimal.
84.3.
Okay, I'm told that the sample mean, go ahead and leave it to 1 decimal place. I'm told if we added all these up and divided by 16, I heard 1,084.3. Because in my last class it was point 0.4. Okay.
That's why I asked if you would round it up. That's what I asked.
Oh, yeah, if the next, always round appropriately depending on whatever the next number is. If the next number is 5 or higher, go ahead and round up. All right, so you should be able to finish the problem from there, so I'll pause the video now. All right, so the margin of error, you were supposed to go, let's see, we want 98% confidence interval, so that means we need z-score 2.33. All right, so hopefully you did this, and you did 2.33. Standard deviation goes in the top, so 120. Sample size goes here. Whoops, parentheses are no good right there. So that should give you the margin of error. Give me 1 decimal place. What is it? What was 69.9? Okay, so 69.9 is the margin of error for the SAT scores. So if I want the 98% confidence interval, I'm going to start with my sample mean. I'm looking at the X bar up here. So the average for my sample is 1084.4. And then I will add or subtract my margin of error that I got.
Wait, why didn't you run it like 70?
I just decided I want that accuracy. So if I subtract 69.9, what do I get?
14.5.
Okay, and if I add, what do I get?
1154.3.
So, if I asked you to interpret this in the context of the problem, in other words, write a sentence, you would say we can be 98% sure that the actual average SAT score is somewhere between 1024 and 1154. All right. Let's skip down to number 6 because we're running low on time and number 6 is different. So there's always that one problem that's written in reverse. So let's learn how to do that because this is bound to show up on the test. So this time they give us all this information, but we're being asked to find how many people, all right, how many incomes must be found if we want this confidence interval. In other words, we're being asked to find the sample size this time. So here's our formula. The margin of error is equal to the z-score times the standard deviation over the square root of the sample size. But this time it's n that we're looking for. We're given everything else. It's a little tricky to see where the margin of error is in this problem. Now remember, the margin of error is always that thing that we're adding or subtracting. So here's where the margin of error is hidden. It says the sample mean is within 500. Within 500 means it could be 500 more or 500 less. 500 is the margin of error. Within 500, that means give or take 500. Anytime you're give or taking something, that's your margin of error. So the MOE is 500, so that goes here in the formula. The z-score, we want 95% confidence, so we just peek at the chart. That's that 1.96, so we'll use that. True, so we have 1.96. And then we have, okay, the standard deviation. Did they say what that is?
6,250.
Over the square root of the sample size. Somehow we have to take this and solve it for the sample size. Now remember, this is like 1.96 over 1. So one thing I could easily do is just go ahead and multiply these two numerators together. Just multiply the 1.96 and the 6,250. So help me out because I don't actually have a calculator right now. Just multiply 1,000, sorry, 1 point,
12,250.
thanks, you know what I'm trying to say. 12,250 over the square root of n. Do you remember the shortcut that I keep trying to get you guys to memorize when you have 3 numbers like this and you have the variables in the bottom? Yeah, this comes up over and over again, so it's really worth memorizing. That you have a number equal to a fraction. You will have a valid equation if you take the denominator and switch it with the number that's by itself. So if we use that shortcut, then what we have is square root of n is equal to 12,250 over 500. Okay, does that work out to be a decent number?
25.24.
All right, is that without rounding?
That's without rounding.
Okay, great. So 24.5 exactly. So of course, how do I get n now? You square it. So we'll just square both sides. So that gives us n is equal to what? Whoa,
No, 5.
it's got to be bigger. We're doing 24.5 squared.
Oh, oops, I 600.25.
600.25. Now remember, n is a number of items, okay? A number of values. So you can't have a decimal for this.
600.
So just 600. All right, that's it.